Hello, my name is Jessica. I'm a fully qualified maths teacher, and today we are going to look at binary numbers. So this is what a binary number looks like. So it could look like that. It's made up of ones and zeros. Then we have got where questions they'll say, can you convert this binary number into a decimal? Some pupils find that quite confusing. So all that means is putting it into a number like 27, 19, any normal integer. Okay, so in binary, all of the numbers are to the base of 2, and we start with the power of 0 and we work up. So we have 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and so on. You're kind of writing backwards, like almost into yourself. There's a couple of ways of doing them. Some kids like to draw a table for them. I always tell the pupils that I teach and tutor to remember that binary is to the base 2 because there's two numbers in binary, 1 and 0. So it's to the base of 2 because there's two things. So it might work for you. So the first number is 1 because 2 to the power of 0 is 1. So remember with your indices, anything to the power of 0 is always 1. 2 to the 1 is 2. 2 2s are 4. 2 cubed is 8. 16. The next one will be 32. 64 and so on. So you can see that basically we are doubling. So 1 and 1 is 2, 2 and 2 is 4, 4 and 4 is 8, 8 and 8 is 16, 32, 64 and so on. Okay, so say you're in your exam and they say to you, write the number, convert the following binary number into a decimal. So they'll say go from binary to decimal. Okay, so first thing we need to do is write out our binary numbers. So we remember binary numbers are 2 to the power of. How do we remember it's 2 to the power of? Because there's two things in binary, a 1 and a 0. So some kids like to draw a table. I personally don't. So the first number, 2 to the power of 0, is 1. So we've got 1 and then 2, 4, 8, 16, 32. So then we've got 1, 0, 1, 1. So do you see I started that binary number and wrote it backwards, okay? So then what we say is 1 times 1 plus 4 times 1 plus 8 times 1. So we've got 8 times 1 plus 4 times 1 plus 1 times 1. So that's obviously 8 plus 4 is 12 plus 1 is 13. So 1101 as a decimal number is 13. Okay, next one. Convert 10011 to a binary number, to a decimal. So put that into a decimal number. So it means we're going from this binary number consisting of ones and zeros into an integer. So let's write out our binary numbers. I don't know how many different colors to show you, and we'll go 1 and then 2, 4, 8, 16, 32, 64. After that would be 128. So let's write this number. Again, we're going to go from left, so from right to left. So 1, 1, 0, 0, 1. So we've got this one, and this one, because anything times 0 is 0, so we don't count those ones. So 16 plus 2 plus 1 is 19. So 10011 as a decimal number is 19. Okay, let's do another one. What if we had 10111? Okay, 1. We'll make it a bigger number. So again, we want to write that as from binary to decimal. So let's write out our binary numbers. Do them in red. So remember, it starts 2 to the 0. So our first binary number is 1, then 2. 2 and 2 is 4. 4 and 4 is 8. 8 and 8 is 16. 16, 16 is 32. 64. 128. Let's write our binary number in. Again, backwards. So 1, 2, 3, 4. 1, 2, 3, 4. 0, 1. So 32, 8, 4, 2, and 1. I'm just going to add this in my calculator. So we've got 32 plus 8 takes us to 40, plus 4 is 44, plus 2 is 46, plus 1 is 47. Oh, didn't need the calculator. So that as a decimal is 47. Okay, so that's when we go from binary to decimal. What if we have to go from decimal back to binary? So from decimal, oh dear, I wrote that terribly. From decimal to binary. Okay, so if we said write the number, say 17, as binary. So what we need to do is, again, let's write out our binary numbers. So it starts with 1 because the base is 2, because 2 things in binary, 1 and 0. And we always start to the 0. And anything to power 0 is 1. So 1, 2, 4, 8, 16, 32, 64, etc. Now, how we do these ones is like this. So we say we've got 17. So we can't start with 32. We have to start with 16. Okay? Because 32 is too large. So we start with 16. Okay? Because if we did 32 plus something, that's going to give us a number bigger than 17. So you always go to the number that just falls under the number that you want. So if 17 is what we want, we start with 16. How many more do we need? We just need one more because 16 plus 1 is 17. So 17 as a binary is 1, 0, 0, 0, 1. Okay? Let's do another one. Let's write 27 as a binary number. Okay, so again, decimal to binary. So first thing, let's write out our binary numbers. 1, 2, 4, 8, 16, 32. By the way, the table I was referring to earlier would just look something like that. And so it is basically what we're doing, but I just don't tend to waste time drawing out the table. So then we say 27. Okay, so do you see how 32 is too large? So we have to start with 16. So we put a 1 there. The best way to do these is to type the number into your calculator. So I've typed in 27. And then you want to just subtract the 16, leaves you with 11. So we'll go for 8. Let's take 8 away, leaves us with 3. 2 and 1's 3. Stick in a 0 in the number we don't need. So it's 1, 1, 0, 1, 1. So I type the number into the calculator, 27, and every time you put a 1 under the number, just subtract it. If you don't have a calculator, you can do a wee sum at the side, or you can do it in your head. Let's do another one. Say it was like 63, and I want that as a binary number. So we'll go something a bit bigger. So let's start by writing out our binary numbers. 1, 2, 4, 8, 16, 32, 64, 128. And we want 63. So do you see how 64 is too big? So we start with 32. So we type 63 into the calculator, take away 32, leaves us with 31. Let's take 16 out of it, leaves us with 15. Let's take an 8 out of it, leaves us with 7. 4, take a 4 out of it, leaves us with 3. Wow, it's quite a nifty one. So it's 1, 1, 1, 1, 1, 1. That is 63 as a binary number. In your exam, if you're going from our, let's go back up, say we're going from our binary number 10011 to a decimal, you could then check your paper by taking this 19 and converting it back into a binary number. And if you get the binary number they asked for, then you know you've done the question correctly. So hopefully that's helped you understand binary numbers better. So remember, binary numbers are always to the base of 2, and they start off as to the power of 0. So 2 to the 0 is 1, then 2 to the 1, 2 to the 2. So they are 1, 2, and then 4, and then 8, 16, 32, 64, and so on. If it's asking you as a decimal number, it just means an integer. Binary consists of 2 things, 1 and 0. So that's how I remember it's to the base of 2. And I hope that this helps. So I hope all your revision is going really well. And if you've any other topics you'd like me to cover, please feel free to comment below. Take care and all the best.